Hello students, so here we are going to do an important sum based on application of trigonometry, that is nothing but the cloud sum. So there are total 2 examples. Here I am doing the second example, and for the first example students I have given the link in the description box below. So let us see the second example. The angle of elevation of a cloud h meters above a lake is alpha. From the same point, the angle of depression of its reflection in a lake is given as beta. We have to show that the height of the cloud is nothing but h bracket tan beta plus tan alpha upon tan beta minus tan alpha meters. Okay, so the most important thing for any sum based on application of trigonometry is nothing but the figure. So let us draw the figure step by step. So first let us show a lake xy, then we have a point which is at a distance of h meters above a lake. So that is point A. So AQ is nothing but small h. Now let us have point C as nothing but the position of the cloud. So CP is nothing but the height of the cloud above a lake. I am going to take that height as capital H, and this is what we have to find out. Okay, so we'll be finding capital H. Now point A is nothing but the point of observation. So whenever you're standing at point A, your line of vision is horizontal. So from A we are drawing horizontal, means perpendicular to CP. So that is AB is perpendicular to CP. Now from point A, when you're looking at the cloud, means you're looking up. So that is called as angle of elevation. So that is nothing but alpha. Now let us take point D as the position of the reflection of the cloud, okay, below the lake. So that distance is nothing but dp. Now dp is also capital H by a simple law of reflection of a plane mirror. What is that law? That object distance is equal to image distance. So if you see above a lake, the object distance is nothing but cp. So the image distance, that is dp, should also be capital H. Now from point A, when you're looking down at the reflection, okay, yes, so that angle of depression is called as beta, that is given as beta. Now have a look at quadrilateral AQPB. So quadrilateral AQPB is nothing but a rectangle. So I can say that opposite sides are equal. So if AQ is small h, BP is also going to be small h, right? So we have capital H and small h. Now have a look at triangle ABC. So if you want to find out CB, see the figure carefully students. If I want to find out CB, that is going to be capital H minus small h. So I'll write over there CB is nothing but capital H minus small h. Similarly in the other triangle, that is triangle ABD, if I want to find out BD, okay, so we have BP as small h and PD as capital H. So I can say that the total, that is BD, is nothing but H plus H. Okay, so with this we finished with the figure. Now let us write down whatever we have taken in the figure in the form of theory. That is, let A be the point of observation, H is the point of observation above a lake, point C is nothing but the position of the cloud, D is nothing but the position of its reflection, and capital H is nothing but the height of the cloud above a lake. That is what we have to find out. So what I'm doing is, students, I'm just taking these 2 triangles, the yellow triangles, for the calculations. Okay, yes, so we have 2 right angle triangles. In both the triangles we are going to use trigonometry. Okay, so let us have a first triangle, that is triangle ABC. Okay, so in triangle ABC I'm using tan alpha, that is tan theta. The formula is opposite upon adjacent. So I have capital H minus small h upon AB. Okay, now the angle is alpha. Okay, it is not a standard angle 30, 60, 45. So we don't have the value of that. So I'll keep this as it is. Okay, and I'll cross multiply. So what I'll get, AB as H minus H upon tan alpha. So I got the value of AB. Now let us take the second right angle triangle, that is triangle ABD. So in triangle ABD, I'm using the same thing, tan beta. Okay, again we don't have the value of tan beta. Okay, so the next step what I'm going to do is just cross multiply. So in this step what we got, tan beta as capital H plus small h upon AB. You can see the figure, opposite upon adjacent. Okay, so if I cross multiply, I get the value of AB as H plus H upon tan beta. Now, if you see on both the sides, okay, the left and the right side, both the sides we got the value of AB. So in the next step, what I'm going to do is I'm going to equate both the values. Okay, so let us equate both the values. So what I'll get, H minus H upon tan alpha equals to H plus H upon tan beta. Now the question is, we have to find the value of capital H. That is nothing but the height of the cloud above a lake. So let us cross multiply. Okay, so when I cross multiply, what I'll get, capital H tan beta minus small h tan beta equals to capital H tan alpha plus small h tan alpha. Okay, so this step is simply cross multiplication. Okay, now what I'm going to do is I'm going to bring capital H on the left hand side, means capital H terms on the left hand side and small h terms on the right hand side. Okay, so let us shift the terms and see what I get. Capital H tan beta minus capital H tan alpha equals to small h tan alpha plus small h tan beta. Okay, so now what I can do is I can take capital H common from the left hand side and small h common from the right hand side. So when I take common, I get capital H in the bracket, what we get is tan beta minus tan alpha. On the right hand side we have small h bracket tan alpha plus tan beta. Now we have to find the value of capital H. So simply I'm going to shift that term on the right hand side. So I get capital H equals to small h bracket tan beta plus tan alpha upon tan beta minus tan alpha. So we got the height of the cloud above the lake. Okay, thank you students.